All right, again, we don't have too much to go on here, but what I want to do is I want to show you, I quickly during the break wrote this little example, and hopefully you understand everything that's in here. Now it's wordy. I wouldn't actually code like this, but I did it to show you some stuff. So we've got here int size equals 0. And then we're going to write, so this is going to appear on the screen. Enter size. 1 for small, 2 for medium, 3 for large, 4 for extra large. Does that make sense? All right, you might say, well, why didn't you say MS? We could have done it. I just did it this way. All right, so size equal convert to int 32 read line. Then if size equal 1, write small. If size equal 2, write medium. If size equal 3, write large. If size equal 4, write extra large. Does that make sense? Okay, first thing to notice, this is written incredibly badly. What do I mean? I should be saying this. And you might say, well, it's not. Yeah, it is a big thing. What if it's a 1? Let's pretend we have just the ifs in here, and let's say we entered a 1. Okay, so it says you are a small. It still has to check if it's a 2. It still has to check if it's a 3. It still has to check if it's a 4. That's waste. You're making the processor waste time doing checks it doesn't have to make. It's like if I said, Evan, go over there and turn the lights on. Let's say they were off. So he turns them on. He sits down and I go, Evan, go over there and turn the lights on. It's going to say they're already on. Well, we're making the system do the equivalent of that. All right? So that's the first thing. So that's already made it better. Now, the other thing is, what if they don't enter a 1, 2, 3, or 4? What if they enter a 5? Nothing happens, correct? So we should put in here an ending else that says write line, something like, I don't know, unknown size. Does everything that's in there make sense? This is what I'm asking you. Does it make sense? Yeah? All right. So there's another way that you can write this, and that is to use what's called a switch statement. So we again ask you what your size is, etc. But now look how it changes. We do what's called a switch on the size. So this first one here, this is like saying if size equal 1, else if size equal 2, else if size equal 3, else if size equal 4. Many people find that using a switch like this makes your code easier to read. Okay? So let's say that you entered a 1 here. So it's going to come in and it's going to say you are a small. Break means, now get the hell out of this switch statement. If you left the break off, so if you left this off, and 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 you put a 1 in there, it would say, you are a small, you are a medium, you are a large, you are an extra large. So whenever you use a switch statement like this, which again is another way of writing an if, all right, you have to make sure you got a break at the end of each one of them. Now, did you notice here, we put a final else in there that said unknown size? We can do that here too. But if we do it here, then it's a special word that's called default. So we'd say write line, unknown size. Now, technically, we don't have to put the word break here because we're at the bottom anyway. But most developers still do. Can you look at this and look at this and understand the difference between the two? I'm asking you that. Can you understand that they're doing the same thing? When you take your test next week, I will set it up so there will be at least 2 times when you have to do something like this. And I will say for one of them, choose an if, and for one of them, choose a switch. Okay? You will be forced, for lack of better words, to do that. All right? Now, one place you'll never use this, just so you know, in this language, and again, every language is different, but I wouldn't want to say this. Okay, I'm going to say here int grade equals 0. All right, and let me just steal some code from here. Oops. All right, enter, I'll say here, enter grade. And we'll even let this user know 0 through 100. All right, so we're telling them to enter that grade. And grade equals, again, convert, etc., etc. So we say if grade greater than or equal to 90, right line, you got an A. Else, if it's greater than or equal to 80, you got a B. Else, if it's greater than or equal to 70, you got a C. Else, if it's greater than or equal to 60, you got a D. Else, and these should all be else's, sorry. Else, and no, this last won't be an else if, this will just be an else that will say you got an F. And what? Semicolon, 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 semicolon. And that's an F. All right? Now, you might look at this and go, wait a minute. What if I put in 83? Is it greater than or equal to 90? No. It's greater than or equal to 80. Yeah, so say you got a B, but it's also this. Remember, when you do this has got to print, or 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 this does. That's it. So it's impossible for using an if like this to say you got an A, you got a B. You can't have that. That's why I don't have to say if grade is greater than or equal to 80 and grade is less than or equal to or less than 90. I don't have to say that. It's redundant to say that. All right? Does this code make sense? Yes? All right. So I'm going to grab the same code and tell you why you don't do this using a switch statement. So we got the same thing here. So we got all this. We want to switch, and you'll see real fast why we wouldn't do this on grade. All right, I'll leave the other one over here. Okay, and I'm not making this up. This is the way you'd have to do it. You'd have to say, come on, there. I'd have to come in here and say, case 90, case 91, case 92, case 93, case 94, case 95, case 96, case 97, case 98, case 99. I'm assuming that the best grade you can get is 100, case 100, right line, you got an A. Do you understand why you wouldn't use this? When you work with a switch, you cannot use ranges. Okay, you've got to have literal values. If you want to work with ranges, you use an if. All right? If you have a discrete number of values and it's small, some people find that using the switch as opposed to using using a switch as opposed to an if is easier. It's largely a matter of personal preference. All right, that's what I want you to know. Okay. All right, so I gave it to you already. They use freshman, sophomore, junior, senior, or else invalid, which is fine. Then they go back and they rewrite it using a switch. That's all. The switch has to be within curly braces, just so you know that. All right. Case label, that's each case. That's like if year equal 1, if year equal 2, if year equal 3, if year equal 4, else. It's exactly what it means. So they've got their own stuff in here, and it's not any better, it's not any worse than what I just showed you. Again, you have to put the break in there. I already told you what happens if you don't put the break in there. Also, the default must be last. If I put the default first, default means just do it. So if it hits the default, it does whatever is there. So the default must come last. Using an enumeration with a switch. Well, this is going to result in code that's easier to read because now if it's accounting or CIS or marketing, it's English-like. All right? So I could have created an enumeration like this that said small equals 1, medium, large, extra large. And then that could have been size here. Then I could have said case size dot small instead of size equal 1. So when you use an enumeration, it can make your code more self-documenting. That's all. All right. Now let's look at the conditional operator. We're almost through, I believe, with the chapter. We're on page 168. And we'll talk about this and the not operator and then some things you should avoid. We got about 10 more pages to go. All right, I'm going to ask you a question in just a second, and it's going to almost, you're going to give me an answer, but it's almost going to sound like, what are you talking about? This is stupid. But if I say this, int num1 equals 10, int num2 equals 15, all right? Int max equals 0. All right, my dumb question to you is, which is bigger, num1 or num2? Usually when I ask that, people think it's a trick question. It's not meant to be. So I would say num2, okay? And if I said to you, okay, your job right now is to explain to somebody who has no idea what numbers are why num2 is greater than num1. If I said, could you do that? You could try. You probably would have a hard time doing it. I know I would. All right. Remember that sometimes explaining things to the computer makes a lot of sense the way you write it. Sometimes it doesn't. So if I come through here and I write this, if num1 is greater than or equal to num2, max equals num1. Else max equals num2. Right line, the biggest number is plus max. Now, there's nothing wrong with that. And that's going to write down the biggest number is 15. Does that make sense? Look at it. Any questions on that? Because I'm about to take this, that if I'm counting right, it's 1, 2, 3, 4, 5, 6, 7, 8. I'm about to take that and rewrite it as one line of code. All right? So I can take this, I'll leave it here so you can see it. Put it at the top, but I can rewrite all of this that you see in gray as this. All right, max equals num1 greater than or equal to num2 question mark num1 colon num2. So I am rewriting those 8 lines as this one line. This says, this line right here, putting this in the parentheses like that, that is the same thing as saying this. All right? After the question mark comes what you do if that's true. So if that's true, take num1 and assign it to max. If it's false, you do what comes after the colon. You take num2 and you assign it to max. Sometimes, you can't use this all the time, but sometimes this results in a lot less code. It's called the conditional operator. It's also called the ternary operator because it has 1, 2, 3 operands. It's also called the question mark colon operator. If you find it confusing, just don't use it. But again, it can oftentimes result in you writing a lot less code. All right. So that is explained, and they give their own example on 168 and 169. All right. Okay. You already know this because I asked you the question before. If I say this, Boolean, and I call it is married. What are the two possible values for that? True and false. So we say, makes sense, okay. So, if I wanted to say this, while is married. Okay? I mentioned this to you before. This is a shortcut for while is married equal true. So that's basically saying as long as is married is true. Don't worry about the while. That's what we're going to go over tomorrow. All right? What if I want the reverse of that? I can say while not is married. And that's the same thing as saying false. So when you use the question mark, when you use the exclamation point like that, it means not. Not true means false. Not false means true. So it's called also the inverter because it changes the value to the opposite of what it was. All right, it's kind of like doing this. If I say x equal 12, y equals minus x, would you agree in this case that it's what we did was we changed the sign? Okay, so x is 12, y is minus 12, correct? What if we do this? Minus minus means plus. So that's still going to work. That's what we're doing with this symbol. We are taking anything that's true and we're making it false. We are taking anything that's false and making it true. So you use this, and again, it's the not operator. You use it basically to take Boolean values that are false and make them true, or values that are true and make them false, or to check like this. Does that make sense? All right. So that was the conditional. There's the not operator. It's what I just showed you with the not sign. All right. And the last things that are in here, so we're all the way up to page 171. So now we have about 5 or 6 pages to go in the chapter. All right. So here are some common mistakes you can make. If you do an if statement, and we already looked at this before, you need 2 equal signs. Everybody hear that? You need equal. Equal means check for equality. 1 equals means a sign. This, believe it or not, that's always true. That just says, can I take 1 and assign it to size? That's all it says. And yes, I can. That is checking for equality. So, as they mention in the book here, quite often what people do is they use a single when they mean to use a double. All right, so don't do that. Second thing, don't ever do this. This will actually give you an error. Don't put a semicolon at the end of an if statement, because all that says that this line is done. But then it sees an else and it says there's no if that goes with it. You go, yeah, it's up here. Not when you put the semicolon. So never put the semicolon, and don't put it at the end of any of the else's either. All right. Third, what if we do this? And again, this is the kind of stuff people do. All right, let's say I left this off. I'm going to get rid of these curlies right here. And now I'm going to write kind of stupid, but you get the idea. I'm going to get an error there. And the reason I'm going to get an error is if I put in, it doesn't matter, if I put in a 1, it's going to write you are small. It's always going to write good for you. And then it sees an else and it says I already finished that if. If you leave the curly braces off at if, it means it's just the next line. So if I wanted to say both of these, I would have to. I would be required to do that. This one is not necessary. This is not necessary. This is not necessary. This is not necessary. Hopefully that makes sense to you. Even though they're not necessary, I'd recommend always using them. All right. Other types of things. Performing a range check incorrectly or inefficiently. What does that mean? Again, I want to show you an example. We looked at this, and this was a 1, 2, 3, 4, 5, right? Well, what I could have said is something like this. If x equal 1, not x, I'm sorry. If size equal 1, or size equal 2, or size equal 3, or size equal 4. Would you agree if it's one of those, we put in a valid size? Would everybody agree with that? Based on what we had here? I would. All right. So, if it's equal to that, or it's that, or it's that, or it's that, we could say right line inputted size was valid. All right, not a problem. Then we could say else right line inputted size was invalid. And that's totally legit. Nothing wrong with doing that. What you'll notice is there's a better way of doing it than that. All right? Instead of putting this, which is fine to do. All right? But I'm going to come down here and I'm going to put in some more code down here. Why couldn't I have just said if size is greater than or equal to 1 and size is less than or equal to 4? That's a range check. This is an inclusion check. It says, is it included in one of those? This is a range. This says 1 or 2 or 3 or 4. But hopefully you realize when you take a look at it that what it does more than anything else is it results in less code. If I could type this, if I can type this, or I can type this, I'm going to choose the second one. It's even worse. What if we had 10 sizes? I'm not going to write that, but if it's 1, or if it's 2, or if it's 3, or if it's 4, or if it's 5, or if it's 6, all the way to 10. That's a lot to code. All in here, all I have to do is change that to that. Okay? Also, when you're doing ranges, and if you want to see if something falls within a range, I always put in another set of parens here. You don't have to. All right? This is an inclusive range check. This says a number between 1 and 10. Does that make sense? Does that not make sense to anyone? If I do this, that's an exclusive check. So I'm checking for stuff that's not in range. This checks for stuff in range check. This is an out of range check. That says either negative numbers or numbers greater than 10. You have to be able to start understanding the difference between and or, because it's one a lot of people make. And what'll happen is, as you're doing this, it'll become more second nature. And you'll be like, hey, I could probably do this. You should try it, see if you're right or not. All right? And that's what they mentioned in that section there. So the last thing that's in here, so that's what I just showed you. The last thing that's shown in the chapter on page 175, decision-making issues in GUI programs. All right? You write the same kind of code. Many people like to write console programs because you see the English right in front of you. You know what I'm saying? All right? So we could do this. We could write a console program that basically looked like one of these. Okay? We could write this as a GUI. We're probably not going to write all of this stuff as a GUI. It's just too much to write. People just don't. But if all we say for the GUI is if we have a label that says size, and we don't let the people know that it's a 1 for a small, etc., they're probably not going to make the program work. So sometimes writing a console program results in a program that's more straightforward. Sometimes. Sometimes not. All right? And that's pretty much what they talk about with these decision-making things on 175 and 176. All right? Then finally, on the bottom of 176, in your book, they have a program. The author oftentimes ends these chapters with programs. You do it. If you're struggling, I'd suggest try to find the time to at least read through it. You may have time to key it in, you may not, but at least go through it and look at it. So that's right there. They show you what the GUI will look like. They show you every bit of the code. You use an enumeration. You use a switch. All right? So hopefully, if you're having problems, hopefully, that will help you. All right, let's quickly look at these review questions. So I'm on page 181. Just so you're aware of this, yesterday before class ended, I emailed you the test review for Chapter 4. We're going to look at that in just a minute. So I'm on page 181. Well, this will be fun because I thought I did all these beforehand, and this is what I didn't do. So, number 1. What is the output of this? All right. Well, if A is 3 and B is 4, they're not equal, correct? All right. So this line won't print. So the output will be B, white. So number 1 is B. Number 2, what is the output of this? 3 is less than 4, so it should print black, white. Right there. So number 2 is C. I oftentimes tell people, play computer, because that's what I'm doing. All right. A is 3, B is 4. Is A greater than B? No. So we don't write black, we write white. So number 3 is B, white. So number 1 was B, number 2 is C, number 3 is B. Number 4, if the following compiles correctly, what do you know about X? Yeah, it's got to be a Boolean. Because whatever's in these parentheses must be true or false. Yeah, you are correct. B. So, the first page are B, C, B, B. Turning to the next page. What is the output of the following? Is C greater than D? No, 6 is not greater than 12. Since notice what they've done, trick question. See how they put a semicolon at the end of the if? That means the 2 lines under it will always print. So the actual output is C, green, yellow. Number 6. All right, if C is less than D, yes it is. If C is greater than 8, no it's not. So we will write yellow. So number 6 is B. Some of these you may have to take a look at. But however it's easiest for you to figure it out, try taking a look at it. Number 7. If E is less than F, so yeah, that's true, and F is less than 0, that's not true. Since it's an and, they must both be true. So we do the else, which means that the result is B, orange. Number 8. Is E less than F? Yes. So we don't even have to check the other one. So the output is A, red. Because it's an or. Remember, with an and, they both sides, what's to the left and to the right of the symbol, have to be true. With an or, either one can be true, or they both can. All right? So, bless you. Number 9. Which of the following expressions is equivalent? All right? So that's if this and this. B is illegal. No, and it isn't H because it would have to be and. They both have to be true. If this is true and this is true, you do this. So if this and this, you do this. So number 9 is A. Number 10. I hate questions like this. Which of the following assigns true to a Boolean named is valid when the ID number is both greater than 1,000 and less than or equal to 9999, or else is equal to 1, 2, 3, 4, 5, 6. You know what? That question just stinks. So I'm putting an X in it. I would never give you anything like that. That's just like, that makes my head hurt to do with questions like that. Number 11. Which of the following is equivalent to this? I didn't mention this to you. When you've got Boolean expressions, and you've got and you've got or, and you've got not. If you don't use parentheses, you do not first, then you do and, then you do or. That's the order in which you do those. So if I have if x is less than 3 and y is great, that's fine, it's greater than 6, or z equal 10, or not b. I do the not first. I purposely put no parens in there. So I do the not first, then I look for the and. So I do the and second, then finally I do all the result of that and do the or third. First, second, third. And it actually makes sense if you think about it, because not is the most conservative. Or is the most liberal. All right? So that's the order in which you do them. So the question was, which of these two is equivalent to this? All right. So we've got A or B, not and or. So remember, we have no nots in here, so we want to do the and first, then we do the or. So this one is definitely equivalent. C is. And I think that's the only one. So I think at least looking at it, 11 is C. All right. 12. How many cases would a switch require for the equivalent of this? The answer is 2. It would be case, 1, and default. All right, so the answer to 12 is C, 2. 13. Falling through a switch case is prevented by what word do you put on the end? 13?
Default.
No.
Break.
Break, there you go. A, break. 14. If a test expression in a switch does not match any of the case values and there is no default value, what happens? The answer is C. It acts as though it's not even there. It just continues on with the next statement. It doesn't do anything. Number 15. Which of the following is equivalent to this statement? All right. D equals M equals 0. The answer is D. Number 16. Which of the following is equivalent to this? A is less than B and B is less than C. This one is. And believe it or not, I think this one is. I think A and B are both correct, so the answer should be D, 2 of these. Again, I would never give a question like that. For lack of better words, they're brain teasers. And typically when people take tests, I don't care if it's a written test or a hands-on, that's the last thing in the world you want. All right. 17. Which of the expressions means if item number is not 8 or 9, add tax to price? So it's not 8 and it's not 9. It'd be this one right here. So the answer to 17 is B. Number 18. Which of the following means this? If item is 1 or a 2 and quantity is 12 or more. So if item is a 1 or a 2, none of them are going to work because you're going to need parentheses in here because it's always going to do the and first. So I don't think any of these are right. Number 19. Which of the following means if number is 5 and zone is 1 or 3? So if number equals this, and we'd want to put the parens in here. So B is the one that's correct for 19. And number 20, which of the following results in tax being added to price if the integer is not 100? A, I believe. All right. Again, these can drive you nuts taking a look at them. At least me it can. Maybe not you. All right. And if you have it, like I said, if you look here, come on. Thank you. All right. I sent you this yesterday. You all got this. So you all got an email yesterday that's got the test review for Chapter 4. So I'd like you, if you would please, see if you can find that. So again, this is what will be on your test that you will take Friday. All right, Jesse, remind me, I will print off for you a copy of the one for Chapter 3 after we get done with this. So what flowchart shape is used for alternative courses of action? The answer is the diamond. All right, stupid question, but that's the one they put in here. Number 2, what is a block? A block is one or more statements that go within curly braces. That's what a block is. One or more C-sharp statements that exist within or between, however you want to say it, curly braces. Number 3, when nested if-else statements, within nested if-else statements, each else is automatically compared with the most recent unpaired if. That's a very confusing line. What that means is if you don't use curly braces, the system just maps up the else with the nearest if. So if you don't want that, you use curly braces. Number 4. How is a C-sharp switch statement terminated? And it's via the break statement. You already know that. We looked at that just a minute ago. Number 5, can you have more than one and or more than one or? The answer is yes, certainly you can. So number 5 is yes. Number 6, it's a long answer. I'll leave it up there for a minute so you can key in whatever you want to key in from it. There's more here than what the question asked, at least what I see on here. Now, even if you're still typing, if you would please just stop for a second. The people who took the first class know this. The two of you may not. If you look here, that is one question on the test. 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 And that is one question on the test. So in other words, there's 40 questions on the test. 5 of them, the answer is right here. All right, I just want you to realize that. That's why when there's a lot of text here, that's why. Because I'm attempting to answer a lot of questions at one time. I should have really put in here too, what is an if statement, how is it used, etc. I didn't. I don't know why, but it's not there. Number 7, for them both to be true, it's an and. For either one to be true or both, it's an or. Has everybody been able to catch up? Does everybody have number 6 done? I'm not hearing no, so I'll move that up to right there. Number 8, we already talked about that. That's what's referred to for number 8 as short circuit evaluation. Number 9, an and uses 2 ampersands. Don't worry about the non-conditional, but you do need to know all these, I guess. So conditional means 2, non-conditional means 1. And what non-conditional means is don't use that short circuiting that we talked about. Always check both of them regardless. Number 10, again, if you look at number 10, there are 1, 2, 3, 4, 5 different questions answered for number 10. So if you're going to concentrate on 2 problems so far, it'll be that earlier one with 5 questions and this one with 5 questions. Number 11, that's 4 questions. Conditional operator, question mark, colon, also known as the ternary operator. Number 12, it's the exclamation point that's used to show the not operator. Everybody have those? All right, number 13, pseudocode. Just the word pseudocode. 14, just the word flowchart. 15 is dual alternative. So remember, flowchart, diagram, pseudocode, English. '16 switch. '17 is the word governing. And then what's left after that are the definitions, so I will hold off on that for just a second. Put that on the next page. Let you finish up this page if you need to go on here. Does everyone have the first 18 done? Anybody who does not, which ones do you need?
I need 10 and 11 and 12 again.
Okay. So, at the end, last thing here, these are all the definitions. Is that big enough? Can you read that, Josh? Can you read that from back there?
Yeah.
Matt, you can read that okay? Evan?
Make it a little bigger.
If I do this, then you're not going to be able to see all of them, but that's fine. Let me leave up for now. In fact, I'll make it there. So that'll be the first 18 through 24, and then I'll move it again in a minute. That should be big enough, hopefully, for everybody. Again, Friday will be, you will take this test. Tomorrow you'll take the one for Chapter 3. All right, and then tomorrow we will also go over Chapter 5 in the book. I'm not going to write any more code today. This is a lot to throw at you in a fairly short amount of time. So, Jesse, if you want, you can go and you can try to make changes if you want to one or the other of your problems. I'll give you that back in just a minute. I did not get the only people that I got updates from yesterday were Josh and Andrew. I did not get any updated, redone tests from any of the rest of you. I know, Ryan, you sent me one, but I didn't see anything that was different on it.
The only thing I had wrong was the tab word.
Okay, all right. But you didn't have in there the cancel button and the other stuff. Okay, so that's right. That's fine. I'll give you another point. All right. But I did not get anything from you. I did not get anything from you. You didn't. I wouldn't have gotten anything from. So, like I said, that's right now your grades and yours. I'll give you that back in just a minute. Okay. Does everybody have these first three? The ones in gray. Does everybody have those first three? Please look up on the screen. Do you all have the first three? All right, because then I can move these up, and that's the rest. And I'm done. If you need any of them repeated, just tell me. So the rest of the period today, the last hour and 40 minutes or so, will be lab. Tomorrow, you don't have to look, but please listen. Tomorrow we will go over Chapter 5. Then we're going to add to that payroll program, the GUI one. We're going to add a while loop to it, one or more while loops. We are going to add if statements to it. I don't know if I can put a switch in there or not, but if we can figure out one, we'll put that in too. So tomorrow, as soon as you come in, you will take the written test for Chapter 3. Then we're going to look at code. All right, we'll do the, I'm sorry, then we'll go through Chapter 5. Then we'll look at some code. Friday, we will do the hands-on test for Chapter 4, and then you've got lab. Next Monday, hands-on test for Chapter 5, then you have lab. Next Tuesday, we'll do a practice test. All right? And I will give you at least a couple hours to work on it. What I will do probably is I will say, do it either using a console or a GUI. All right? And I'll do it as both so you can see the difference between them. Anybody need any of these that are up here that you didn't get? Any of the numbers 1 to 26? No? All right. Grab this for you from yesterday.
So here's your test. You can either see someone each, but you can either redo this one, the first one, or the second one. I would count and see what you can get